So the first problem goes like this. Bob ate 2/5 of a pizza and Angie ate 1/3. How much did they eat in all? All right. When you see something like how much do they eat in all, like when you see the words in all, it almost always means that you're adding them together. We know Bob ate some, we know Angie ate some. We're trying to figure out how much in all. That means we need to add these two fractions together. So the fractions we have here are Bob is eating 2/5 of the pizza and Angie is eating 1/3 of the pizza. So we're adding these together and we want to know how much did they eat all together. So now we look and see, do we have a common denominator? And we don't. So we need to try to figure out what a good common denominator would be. Now when I look at 3 and 5, immediately 15 pops in my head because 3 times 5 is 15. So over here we'll have 2/5, and we're going to multiply this by 3 over 3 because that'll give me 15 on the bottom. In fact, it'll be 6/15. Then the bottom fraction is going to be 1/3. And we need to multiply this one by 5 over 5. 1 times 5 is 5, 3 times 5 is 15. All right, so now we have two fractions with a common denominator of 15. So we're adding them, so we'll put a plus sign here. Now we have a 15 common, so we'll keep that there. And now we add the numerator. 6 plus 5 is 11. 11/15, that's the final answer because I can't simplify that. So if one person eats 2/5 of the pizza and another person eats 1/3 of the pizza, then altogether we have eaten 11/15 of the pizza. And you can't really simplify that anymore. So again, you read the problem. First you need to identify what the numbers are, then you need to identify what to do with them. All right, so let's read the next one and see if we can figure that out. Jenny drove for 1/2 of a trip and Jane drove for 1/6 of a trip. How much of the trip did they drive altogether? So in this case, we know Jenny drove half of the trip, Jane drove 1/6 of the trip, and notice the last part. How much of the trip did they drive altogether? So just like it before when how much pizza did we eat in all, here, how much did we drive altogether? That's your clue. Together, altogether means we have to add everything up. So since Jenny drove for 1/2, we'll represent that as 1/2. Jane drove for 1/6, and we'll add these together like this. So now we're just back to doing our math. We do not have a common denominator, so we have a 2 and a 6, but we know easily we can change the top one to have a denominator of 6 because 2 times 3 is 6. So we'll put times 3 and times 3, and then on the top that will be equal to 3/6. And over here we don't have to change anything, we just keep 1/6 and we're adding these together. Now, since we have a common denominator, we keep it there. 3 plus 1 gives us 4. So that is the answer, but we always try to simplify. In this case, we can divide the top by 2 and divide the bottom by 2. And so 4 divided by 2 is 2, and 6 divided by 2 is actually 3. So what we get is 2/3. So if we have one person drive for 1/2 of the trip and the other person drive for 1/6 of the trip, all together they've driven about 2/3 of the trip, towards their destination. All right, so let me go and get this out of the way. We're going to do one last problem here. And this one you have to think about a little bit more. There's more than one way to do this problem. I'm going to show you the way I did it. An orange, like an actual orange in your hand, has 9 sections. Now you know what I mean by that. You open up an orange and you peel out the little wedges. There's 9 sections, 9 wedges in this orange. Jane ate 1/3 of the orange, and Ron ate 2 sections. 2 sections. It doesn't give you a fraction, it just tells you 2 sections. How much of the orange did we eat altogether? Right? So we want to find out what fraction of the orange we ate. But the interesting thing about this problem is we know Jane ate 1/3. We know Ron ate 2 sections. So we don't have 2 fractions just to add together like we did in the other problems. We have to think a little bit more. All right? Well, let me ask you this. Let's draw a little picture. Sometimes it's a little easier to draw things down. So Jane is the first person. We know that Jane ate 1/3 of this orange, but we know that that's 1/3 of 9 sections because we know that the problem says that the orange actually has 9 sections. Okay? Now we know also that this other person, Ron, over here, it doesn't give us a fraction, but it says Ron ate 2 sections. So we know that basically we need to add these together, but it's a little hard because here we have a fraction and here we have the number of sections. Well, let me ask you this. If we know that the orange has 9 sections, and we know that Jane eats 1/3 of the whole thing, how many sections of the orange did Jane eat? How many sections? I think you can convince yourself that she actually ate 3 sections, right? Because if you divide an orange into 9 pieces, 1, 2, 3, 4, 5, 6, 7, 8, 9, and they're all up before you, and I eat 1/3, then that's 3 pieces that I've eaten, because 3, 6, 9. It's 3 times I take it out in chunks of 3, 3, 6, 9. So I must have eaten 3 pieces. So Jane actually ate 3 sections, and Ron ate 2 sections. So if we add them all together, 3 plus 2 all together, they actually ate 5 sections. They actually ate 5 sections, but the actual orange had 9 sections. Remember the definition of a fraction. It's part over whole. The whole orange has 9 sections. Altogether, these people actually ate 5 sections. So how much of the orange did we eat? 5/9 of the orange. That's how much we ate. Now, there are different ways to do this problem. You could certainly attack it different ways. I chose to do it this way. We just look at what Jane ate in terms of sections. We look at what Ron ate in terms of sections. We add them together, and we say over 9, because that's the fraction of the orange that we have actually eaten altogether.